In this video, section 6.3, roots. The root of a function is an input that gives an output of 0. The value of x that results in f of x being equal to 0. So we want f of x to be equal to 0. Here's an example function. F of x is equal to 3x plus 17. And we want it to be equal to 0. So we're going to substitute that in. We're going to look at 0 is equal to 3x plus 17. Well, we subtract 17 from both sides. And then we divide by 3. And that would be the root of this function. So if we had a function that looked like x minus 2 and we had that equal to 0, x would be equal to 2. If we had, say, x minus 6 and we wanted that to be equal to 0, x would be 6. If we had x plus 8, we wanted that to be equal to 0, well, then x would be a negative 8. So what we could do is we could come up with a new function, g of x, that has, let's see here, the factors x minus 2 times x minus 6 times x plus 8. So now, let's see here, if x is equal to 2, well, this right here is going to be 0. So I don't know what the rest of these will be, but g of x will be equal to 0. G of 2 is 0. Likewise, if x is equal to 6, this factor becomes 0, so g is equal to 0. And if x is a negative 8, right here, this factor is equal to 0, so g is still 0. The roots of g of x are 2, 6, and negative 8. So when a function is in this form, factored form, we solve each factor for 0 and we find the roots of the function. Let's take another look at this. So we'll take h of x, say, and we'll have h of x be x plus 4 times the quantity x minus 2/3 times the quantity x plus 11. Since this is expressed purely as a product, we can go ahead and find the roots just by solving each factor for 0. Negative 4, 2/3, negative 11. The roots of h of x are x is equal to negative 4, 2/3, negative 11. And this is called the zero product rule. Zero times anything is 0. So a function that looks like x minus r1, x minus r2, so on. This has roots. X is equal to r1, r2, so on, rn, because it's in this form. So what we could do is we could say we want a function with roots x is equal to 3, 81, 9/5 minus pi, and we'll say e to the negative 11. Then that function would be f of x is equal to x minus 3, just x minus each one of these roots, all multiplied together. I ran out of space, but this is still being multiplied here. We've got our function. And again, it has to be in this factored form. Now, what if there's something else on here, like x squared plus 3? Well, these are all still roots. And then any roots of this guy would also be roots of this function. But something like x squared plus 3, if I set that equal to 0, I get x squared is equal to a negative 3. There's no real roots for that. So make sure you have it in factored form, solve each factor for 0, and you found the roots of your function. That's it for section 6.3. Thanks.